Today's day 7 of Unit 7 on factoring. Before we get started with today's lesson, let's go over the homework from last night. So remember, yesterday we did factoring using dots, difference of two perfect squares. So you should always have two sets of parentheses. Remember, one's going to be, they're both identical. The only difference is one is addition and one is a difference. Okay, so the other thing I had you, I'm sorry, I don't like giving 5s and S's, but the other thing I wanted you to notice is questions like 3, 5, 6. They're in a different order than we normally put them, like 1 and 2. So I just want you to make sure that, remember, whatever the square root of the front goes in the front. Square root of the second term goes in the back. Okay, remember, order matters because it is a difference, so be careful with that. Okay. Additionally, once we got to questions, actually before I talk about that, please make sure when you draw t's as your variable, please make sure it's very, very clear that it is a t, not a plus sign. You can see, I mean, these look almost identical, so that's my bad. Maybe put a tail on the end of it, something that just shows me that you know, have gone through a little effort. Same thing with like a G, a Z, you know, make sure they don't look like numbers, they look like letters, variables. For 12, 0.8, be careful with 12 and 13, those were decimals. Okay, so be careful, still works the same, you can still take the square root. Again, remember, to do that in your calculator, just hit your square root button and just put the coefficient. Don't put any of those variables in. All right, so today's lesson, our essential question is, how do we factor completely? How do we factor completely? So what you're going to notice is, so before we get started, go ahead and do the do now. Okay, one of the biggest things is factoring and knowing when to use which method we have come across, because really we've done about 4 different methods. Okay, so the first one I always want you to look for is factoring out of GCF, which A would be. Okay, so number 1, it's a plus sign. I know that's a binomial, so maybe you're thinking dots. Unfortunately, it's addition, so that can't work. And then the next thing I notice is that I have a variable that matches in all of my terms. So the next thing I'm going to think of is I can definitely take out a GCF. Okay, so I see that my GCF is just going to be a y. So I'm left with 3y squared plus 10. And that's actually as far as I can go. Okay, the next one, hopefully you're noticing this is a perfect square, this is a perfect square, and it is subtraction. So we are going to use difference of two squares, dots. Okay? So again, open your 2 sets of parentheses, square root of the first, x and x, square root of the second, 3 and 3, 1 gets a plus, 1 gets a minus. And lastly, we have a trinomial. Okay? So I'm hoping when you see trinomials, especially when they have a 1 out in front, first look for a GCF. This one does not have a GCF. So we are just going to say, what is the product of negative 30 and the sum of negative 7? Okay, so open up those 2 parentheses. I know it's going to be an x and an x. I know one will be positive and one will be minus because we have a product of negative 30. Okay, so the next thing again I'm looking for is what multiplies to negative 30 and adds to negative 7. Hopefully you're saying a positive 3 and a negative 10. Okay, so those are just refreshing you on the different methods that we've done so far. But let's look at what happens sometimes. Okay, so again, regardless of this being the difference of 2 perfect squares, all right, I want you to see what will happen. And I'm actually going to do this in 2 different ways. Okay, so yesterday we used difference of 2 perfect squares. So I notice these are all squares, so I'm actually going to do this. Okay, so again, I get, oops, sorry. Okay, so we have the square root of 4x squared. So this will be 2x and 2x. And then I have a positive 4 and a negative 4. Okay, so hopefully what you're noticing is these are all divisible. These are all divisible by 2. Okay, so what you would do, so you could take out a 2, okay, and then this one you actually can also take out, oh, that would be a 2, sorry. Okay, this one would also have a 2. Okay, so I'm not factoring by grouping. What I'm doing is I'm taking a GCF out. So when I take that GCF out, these actually have to get multiplied. Okay, so this would actually be my final answer. Alright, but I don't like that answer. So, always, 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 okay? So number 1, take out a GCF. Okay, so watch what happens when I take out this GCF. So I'm going to take out a 4. So that will leave me with x squared minus 4. This is still a difference of 2 perfect squares. Okay, so again, I'm going to keep that 4 out front. I get an x with an x, 2 and 2, 1 is positive, 1 is negative. Okay, so that's my actual final answer. And again, because I took that GCF out, it just makes it so much easier. So when we are factoring completely, this means that it takes more than one step to factor an expression, okay? So as you're going through all of these, I'm hoping that you're noticing you're going to be doing more than one step. So again, these steps right here, this is what you should be thinking every single time, okay? So first, can we take a GCF out? Hopefully you're noticing yes. Okay, the GCF will be 3. So I'm left with x squared minus 9. Okay, now I'm going to check inside these parentheses and see if I can do anything else. Okay, so the first thing I did was I took a GCF out. The second thing I'm going to do, hopefully you're noticing, I'm going to do dots. Okay, so open up your 2 sets of parentheses. Okay, square root of the first, square root of the second. One is addition, one is subtraction. Okay, I'm left with nothing similar in either of my parentheses, so I know that I am done. Okay, and again, most of the time, the additional, the second step after you take a GCF out, I would definitely be looking for difference of 2 perfect squares. Okay, because if it says factor completely and you leave it like that, it is not correct. Okay. So again, we are going to factor completely. So you should be, and I'm not going to say always, but most of the time, that means you're going to have to do more than one step. So I noticed that these all have 5s in them. They're all a factor of 5, sorry. Multiple of 5, rather. So let's take out a 5. So I am left with x squared minus x minus 6. So now I'm going to ask myself, let me get a different color just so it's a little easier to see. Okay, so now I'm going to ask myself, so this is a trinomial, right? Alright, so I'm going to use my product sum. Alright, so what multiplies to negative 6 and adds to a negative 1? Remember, there's a 1 right there. So keep that 5 out in front. I know I'm going to have an x and an x. One needs to be positive, one is negative, because this is a negative 6. So my factors are going to be, let's see, so my factors are going to be 3 and 2, and the larger one takes the sign. So positive 2 and negative 3. So that would be my final answer. Okay. Now, this one is where it gets a little tricky. Okay. So there is no GCF. Okay. I see that it's a difference of two perfect squares. So let's go ahead and do that. Okay, so open up your two sets of parentheses. I see this would be a p squared and a p squared, and then 9 and 9. Okay, now what I'm hoping you notice, so this one is done. Okay, this is done. What I'm hoping you notice is this is another difference of two perfect squares. I would love to tell you that there's a shortcut that you can just go right to the end, but there is not. You have to do dots twice. Okay, so again, open up those two sets of parentheses. So I get a p and a p when I do the square root. I get a 3 and a 3. Okay, and then don't forget to drop down that p squared plus 9. I know that those are two perfect squares, but remember, only the difference can be factored more. Okay, when you get a question like this on the Regent, this will be an answer, but this is correct. Okay, so they always put this to trick you. This is not factored completely. Not to say that it is not equivalent to the correct answer, but it is not the correct answer. Okay, so we're going to do a few more examples. Zoom in on that. All right, we're going to do a few more examples, and then I'll have you finish the next page on your own. Okay, so again, my first step in this one will be to take a GCF out. All right, I see I have a 10, a 20, and a 10, so I can take out a 10. I see an a cubed, an a squared, and an a, so I can take out an a. So that leaves me with a squared plus 2a plus 1. Okay, so keep that out in front. So I want to know what multiplies to 1 and adds to 2. Hopefully you're saying 2 and 2. So we'll get 1 and 1. So we get a plus 1 and a plus 1. If you wanted to further simplify, you could write a plus 1 squared. But again, I would accept the 1 right above it. Okay, so again, this was GCF, and then we did a product sum. All right, next one. So I see that I have a GCF, so let's take that GCF out first. So I have a y, and then I have a y squared minus 25. Okay, I have a binomial. I have a perfect square, and a subtraction. So I can use dots. Okay, so keep that y out in front. Square root of y squared is y. Square root of 25 is 5. 1's positive, 1's negative. Alright, next one. See if I can have a GCF. 3, 18, 24 are all divisible by 3. So I'm left with x squared minus 6x plus 8. So again, I use the GCF, and then I'm going to use product sum. Okay, so open up those two sets of parentheses, and again, ask yourself what multiplies to positive 8 and adds to negative 6. So I have an x and an x. So they're both going to be negative, because I have a positive sum and a positive product and a negative sum. So I'm going to get 4 and 2. That's my final answer. Okay, let's keep going. Alright, so I have an ax squared, 3ax and a 2a. So I can definitely take an a out. So I'll use my GCF. So x squared plus 3a plus 2. And again, I'm going to use my product sum. So again, what multiplies to 2 and adds to 3. Luckily, there's only one set of factors of 2, and they work. All right, keep it going. So I have a 2 and an 18, so I can definitely use GCF. Also, if you notice, if your head goes to dots first, these are not perfect squares, so I know I have to do something. Okay, minus 9. And then, of course, I find out I can use dots. Okay, 2 sets of parentheses. I have an x with an x. Square root of 9 is 3. 1 positive, 1 negative. Again, this is called factoring completely. Okay, hopefully you see that GCF of a 2. So take that 2 out, and I have an a squared minus a b squared. My exponents are even. It is a difference, so I can use dots. Okay, open up those 2 sets. Square root of a squared is a. Square root of b squared is b. 1 positive, 1 negative. Okay, so go ahead and finish page 21, last page of the packet. You can do this with a partner or individually, but please do this now so we can go over this at the end of class.